My name is Derek DeJesús. I'm a project manager and quality control manager for Burr Computer Environments, and you are here for the how to commission a modular data center. I wanted to take us back a little bit to the history of data centers, and this is where I was intrigued with, doing a little bit of research myself, on where did data centers come from? Who thought of this idea? What were some of the driving factors? And turns out it was the government, as always. Back in the 1940s, they were working up Department of Energy, the atomic bomb, all of this. They needed fast computing, and this ENIAC computer system, 150 kW of computing load back then. It's huge. Then you zoom forward 20 years, now you're getting into more of a corporate, privatized environment. This CDC 6600 was delivered to CERN, not the CERN in Switzerland, but a different CERN, I believe. And it had a processing speed of 40 megahertz. I think our iPhones are marketably faster than that even today. 1971 saw the advent of the first wide access network, the LAN. It was installed at a bank in New York, obviously, for the influx of stock trading, broker, banks, management. So they decided to hook up some cables together, but they were doing coax cables and sharing floppy drives. I don't think anyone would think that that's an effective way to transfer data in today's environment. 1980s, now we're getting a little bit more familiar with some of our senior veterans in this auditorium that probably had some of these computers. I fortunately was not one of them, but I saw the Jobs biography movie, so I've seen this Apple II device. The PCs, that was a new evolution. Now you're bringing a computer home. You're not necessarily needing to have to go into a shared space. You can work on your own. So why is there a data center? Why do we need that? So it started to slow down. That growth and that need to share information. You can now work locally. But throughout the 1990s, the internet and everything started to evolve and started to change, and people wanted to start sharing more data. They wanted to share technology. They wanted to play games, the World Wide Web, and obviously banks, government institutions, higher education. That started to drive more technology sharing, and the data centers started to grow. And boy, did it ever grow. 1.5% of the total power consumption in the United States in the mid-2000s was through data centers. It had a target growth of 10% per year, exponentially. So building operators and the banks that were actually purchasing these data centers were like, wait, we can't afford this. There's no return on investment. We're wasting too much energy. We need to start being smarter and find ways to get us back down. How can we slow that growth? So they turned to the computers themselves. They turned to the manufacturers to come up with better products, better servers, better ways to contain heat and the hot aisle, start driving down the PUE, start driving down WUE in each space, find ways to make the spaces more appealing. When you can do that, then obviously you can start to do what we're doing today, which is raising server inlet temperatures, raising the cold aisle humidity temperature or percentage, and you can have more efficient watts per square foot for cooling of your data center. Mid-2000s, then, we talked about this, but this is where they were starting to grow, right? Silicon Valley, the Southwest, a lot of space, cheaper utilities, wind generation was a different alternative energy that they could start supplementing into the power grid. So they started building more data centers out west. Again, in the mid-2000s, Sun Microsystems started to develop what they considered the black box. It housed 280 servers in a 20-foot long shipping container. Ironically enough, though, Google had actually applied for a patent for this technology. It's not really a technology, it's just more of bringing components together in a more effective manner, and that's when the modular data center is really born. Nowadays, you have facilities like this, a farm, sitting amongst a farm. This is really the cloud. You drive through Iowa, Nebraska, Oregon, New York, you'll see facilities just like this. Nondescript concrete bunkers with tons of power being absorbed and consumed. This is where we're at today because of 24-hour news, YouTube, Amazon, Office 365, all of those technologies that you crave and that we need are being driven and stored in these farms. So governments and utilities began to court and say, well, wait a minute, you're building these facilities, you're chewing up our infrastructure, we need to find ways to work together. So the government started offering rebates. Utilities started offering rebates in a partnership with the data center operator and the developer to start driving down cost. So, here's the state of Texas, obviously, a lot of wind power generation. You see the same thing in Iowa, where they're wanting to do more green, more sustainable opportunities. Data centers overseas, closer towards the Arctic Circle, 100% outside air free cooling. There is no mechanical cooling in those spaces. So that is really where we're at today. We're into this place where we're commoditizing even the data center. How fast can we get it out there? What's the repetition that we can produce to get these boxes into the fields, hooked up to the power and online? How fast can we do this? The goal is that these modules can be either a power module or they can be the data center itself. This is kind of where you have a little bit of a discrepancy into where the modular data center is defined. What we're going to talk about today and show you a little bit more are the power modules themselves and how we commission or would go about commissioning those. The challenges that you have when it comes to integrating your services. The idea of the power module is just like anything else in the computer world. Similar pieces of equipment tied together in a more consistent application. It's an off-the-shelf product. Think of it that way. You're Microsoft or you're Google, and you want to have 36 megawatts built. You can't customize that. It needs to be something that you can readily reproduce. You want 4 megawatt data center times 9 gets to your 36. You have N+1, so you build, 40? You have a 40 megawatt site, 36 is available, 1 for capacity, redundancy. And that's what we're talking about here. We're talking about the repetition. You take the box, you put all the components together, and you just multiply that box out. And you deliver it. Where are you delivering it from? Where are you getting it from? Strategic vendors. You're dealing with, Vertiv, Emerson Power Systems. You're dealing with Sun Microsystems. You're dealing with vendors that are strategically located around the world that can deliver these boxes in such a manner that they can go anywhere within a few months. We're talking 2 megawatts from PO to delivery in about 3 months' time. So as you start to pull these together, then you're integrating all of these modules into the data center itself, and now you have a campus. You have that cloud we showed earlier. Now you're bringing it all online, and you're servicing the public. So that's where I wanted to put together a few slides just on the evolution. Now let's talk about the modular data center itself. What are some of the differences when you compare the modular data center to a traditional data center? Size, the footprint. It's a lot smaller, it's condensed, it's compact. The modular power modules in America versus Europe and overseas are a lot bigger. In Europe, it's nice, it's refreshing to see how condensed the Germans can actually put all these boxes and components together versus when you're walking around a site, let's say in Wyoming or in Iowa, when you have all the code clearances and safety that we actually take into account and are affected the size of these power modules. 2 megawatt power module in America is about double the size they are over in Amsterdam. The impact to existing infrastructure is reduced. You don't have to bring in a full or build out a full 30 megawatt site like you would in a traditional data center. You could build it in modules. Scalability and capacity grows. You bring in more modules. So you need to start then looking at, if you're an owner, what are the benefits to going module versus brick and mortar? Templatable designs, templatable submittals, a known lead time, and time to market. Things that can reduce your project schedule, as well as then you can start driving down cost. In that repetitive nature, supply and demand, right? You build 30 of these modules every year, the first module is going to cost a lot more than the 30th. And if you're a Edge Connects or a Digital Realty Trust, you want to know that. You want to know that you can buy these in high volume and bring them out there as you need them. So you work with your trusted partners, MTU Power Systems, Schneider Electric, whoever they might be, to store these, to build these. So what are some of the operational challenges? Well, you need to look at, are you building a colo, colo spaces versus a build-to-suit, single tenant. Even if you're building a space just for, let's say, Microsoft, they might not want their infrastructure tied into a colo. Their fiber needs to be completely independent, their utility needs to be completely independent. They don't want to risk their uptime just for a colo space. Evolution of products. You see this a lot even with cutting edge technology that version 1 and version 1.1 are going to have some nuances, a little bit of challenges. So there's going to be challenges even within your power module itself. And we'll get into some of those later. So now let's get into the commissioning. The commissioning of the data center itself and your challenges that you're going to have when you're developing a scope of work is going to be very similar to what ACG already defines in their guideline. You're going to do all of your standard process and deliverables, design reviews, submittal reviews, system verification checklists, your test procedures, and your site visits. Your scope doesn't really change. So then as you start looking at commissioning data centers, we're dealing with different terminology. We're dealing in levels. Level 1 design phase, if you will. You need to look at the delivery method. Is it design, bid, build? Is it design, build? Design, build are typically the way these go. It's a lot faster. They can turn these around a lot sooner. And if we're talking about a template design, your impact on the design review is going to be very minimal. The contractor and the owner want to get going. So you really have to understand what impact and what scope of work are you going to have in your design review. Level 2, this is the manufacturing. This is the module itself getting built. So you have submittals, or you should be expecting submittals. What's your role going to be on that submittal? Again, if we're talking about a template and a known commodity, Emerson or Schneider aren't going to want to spend a lot of time waiting on your comments. They already know what they're building. They just want to get it built into the site as fast as they can. So you have to react quickly. And again, where do you define your scope? The best part that I've seen are witnessing the factory tests. There's going to be different stages in the factory, if we're talking about a 3-month period of time, where they're building the box, and then they're building all the components in the box, and then they're putting all the components in the box. That integration is really, if you think about it, a functional test opportunity in and of itself. You're witnessing breaker testing, you're witnessing conductor testing, switch bus testing, individual crack and HVAC cooling system testing, fire protection, fire alarm system testing. So integrating your services into the level 2 factory acceptance test is high value, can also be high dollar. You could be spending about 2 months of that 3-month time period in a factory witnessing it come together and witnessing the testing. So maybe you do sampling, maybe you do certain site visits, maybe you pick and choose when you come in and what you do. We'll get into that a little bit later. And then obviously the last 3 steps are level 3, which are field installation of the module as it ties into the infrastructure. Level 4 are the functional testing procedures, and then level 5 would be the integrated systems test. Okay? So we're going to dive now into each of those levels a little bit more detail. So the presentation now takes a spin. It becomes more of me just kind of sharing my knowledge with you, less of a story. So all the information you have in your handouts or online, you can just leave your tip box at the back of the table. That'd be great. But so here's the box. Here is the module itself getting built. So your designer view is going to be focused on what's the capacity, reliability requirements of the box, of the module. Begin identifying your load plan and how you're going to commission, not necessarily the commissioning plan, but how you're going to commission this facility and this component. If you're not doing the level 2s, where are you integrating your services in the level 3 and the level 4? Get a feel for how the module lays out and how it looks. Then, obviously, develop your commissioning plan, and then leave level 1 with draft test procedures, as well as draft checklist, if you will, for the CM or GC to review. Have a good feel for what you expect the vendor to maybe perform in their level 2 activities. And that's your factory acceptance tests. So here are, equipment warehouse, if you will, assembly yard, where equipment is getting built and manufactured. So these are switchgear components. Here's the frame assembly. They're starting to install the buswork. And here's a gentleman actually doing all the internal wiring. So this is one switchgear lineup that goes inside that power module. So all the factory acceptance tests that you're looking for to be done, that now is the time. Test the breakers before they get installed. Typically they're fixed mounted, they're not draw out style. Test the meters, test the TVSSs, test the generators and switchgear. As all the components are, again, brought together, there's going to be an integration aspect as well, where they're going to start bringing in the clean agent, the fire alarm, and all the BMS points. So all of this marshalling section here has where all of the BMS points go out of that switchgear and into a BMS panel. Do all of your point-to-point checks at that panel. Make sure that all the internal wiring is good here, and then all the wiring back to the panel is also good. You're going to be saving yourself a boatload of time during your level 4 testing to prove out that module now in level 2, as well as saving the client time when they're just trying to get this facility turned over. Where are you going to be doing heat load testing? This box is self-contained. There's no windows. There's only a couple doors to get in and out, but it has its own cooling. We're also incorporating UPSs and batteries into here. So this is where our heat is generated for the most part. So they're going to have, N+1 or maybe N+2 cooling capacity. So how are you going to do a heat load test to prove that everything in there works? So you need to start thinking ahead and getting those procedures out to the factory so that either they test it with you not there and they can prove it, or you need to have a plan that it's done during level 3 startup on site. Here's all the switchgear coming together and us doing some additional factory testing. Obviously, power generation module. So here's modules actually delivered to a project site. This is a completed system. Generators are stacked on top of power modules, and here's our power modules coming to our site, pulling up into our data center. 2 megawatt, 4 megawatt, whatever the distribution might be, all dumped in and connected via cabling. So this is self-contained. There is no more work that really goes on in this module except power wiring, BMS, and fire alarm interface to the building. Did that answer your question a little bit?
Yeah.
So level 3s. Level 3 are your field activities, your site acceptance, your site construction, installation. What are the requirements for site activities? Well, it depends on where you're at. In America, a lot of those relate around NETA. You go to the Netherlands, they're going to revolve around NEN 1010. You go to the British Isles and Ireland, it's going to rotate around the British standard. So you have to understand the requirements. Your client end user also have to understand those requirements, as well as the technology available to the contractors to do that work. Not everyone has a primary current injection test kit that they can just roll up. If we go back to our other photo, there's really no way to get that into the switchgear housing anyway to do that test. So you really need to do it at the factory, if at all. Now's the time where you're also looking at doing your final vendor checks. What I mean by that is you tested your power module with a UPS, but there weren't no batteries there. Those batteries are heavy, they have a shelf life, they need to be fully charged. So they're going to get delivered to the site after the power module is installed. There's going to be an installation period of a couple weeks. Then you're going to start doing some site acceptance, startup tests with those. You're also then going to check all of your field conductor testing as it goes back into the data hall or into the switchgear inside the building, as well as other activities. Generator load bank testing still occurs, alarms still occur, building management, automation system, point-to-point, those still occur. You have to then look at non-commissioned equipment and how that's going to affect level 3 startup activities. We're talking about the owner is going to start bringing, not necessarily their deployment and their racks out, but they're going to start bringing out a ton of Panduit. Tons of cardboard boxes filled with plastic so they can start routing their fiber, so they can start building their rack assemblies. The hot aisle containment vendor is going to start coming out with his equipment. They're going to start building their hacks in between all of the RPPs in the data hall, as well as site grounding and lightning protection. So, how much involvement are you going to have in level 3? At my company, we take away all the level 3 activities from our commissioning authority and we do it ourselves internally because we know that there's a challenge as well as a long delay that they could be sitting there. So we support them by doing our own system verification checklist, by witnessing all the level 3 startups, but we're capturing all the documentation. We know that the final deliverable to our end user is such that they need to see all the levels completed. And when our commissioning agent comes back out to do his level 4s, he wants to review that documentation. So we want to have it readily available for him. But we're also looking forward to planning our level 4s. We're planning our functional testing, so we're working with our vendors and our contractors in scheduling. How are we going to execute commissioning? Are we going to use a web-based application like CX Alloy or Clipboard or PlanGrid? It allows for an immediate response to any commissioning issues, as well as statusing percent completes. When you're dealing with a real-time environment of about 5 weeks from start to finish for level 4 testing, you really need to have availability to that information. Equipment fails, you move on, you get somebody to come in and fix it, you go back and do the next one. So defining your scope is very critical because you don't have time to go home and wait for the contractor to fix it, because by the time you get to the airport, it's fixed. You need to get back out there. So the fees we're talking about are large magnitude and scale. You have a large team doing lots of work, and you're there 16, 18-hour days. Request and require a commissioning liaison between the CM or GC to the commissioning team. Have somebody there to support the commissioning authority so that they don't have to run and host the meetings. This commissioning liaison pulls it together, and then you have your commissioning meeting with them. Define your load bank plan, as well as a schedule for moving load banks. We're talking suitcase-style load banks, 150 kW style that hook up to RPPs. The electrical contractor is going to do all of that movement for you, but you need to have a plan as to how you're testing your UPSs, how you're testing your static switches, and what's that schedule going to look like. Who's providing the load banks? Who's providing the transient recorders? Are you going to require the contractor to do it? Does the commissioning authority have to do that? Think about logistics, think about taxes. Anything that comes from America to Europe carries a VAT. You need to figure out how you're going to pay that and then recover that large expense. You also have to look at customs. So then, schedule. We talked about You're going to be running multiple shifts. You also need to have support on these multiple shifts. Your vendors need to be there to support your level 4 testing, so think of that when you're defining your schedule. Now you're actually going to start doing your level 4s. Your level 4 are your functional performance test procedures. Do non-interactive equipment so that you're not affecting others. Do generators while you're doing cracks. Don't try to do the cracks as well as the UPS at the same time. You're going to be counterproductive. UPSs need the cooling as well as you need to provide cooling to the data hall. Test every point. Go through every operational sequence, just like you normally would on a normal project. Define these in your functional test procedures so that everybody understands your expectation, and then provide your duration to do that functional test. Work with the building management or monitoring contractor so that those points are readily available so that he's doing trending and can provide you that data. Only do your functional testing when the BMS is up and running. Don't try to say, well, you can keep working on it. There's not a lot of time. He needs to do all that during the level 3 activities so that you have a good confidence that that system is up and running. Also require logins. Logins for your team so you can all access the building automation system. IR scanning. As you're load banking systems and components, what's the plan for doing IR scanning? Have the contractor or the vendors available to remove panels for you and your team. PPE, if you need to have suits, if you need to have goggles, gloves, think of that. How are you going to get that to the site? How are you going to store it? Do you need to purchase a lockbox? Is the contractor going to give you a trailer? Script out each day's activities with manpower needs. Run daily meetings with your CMGC and go through the commissioning process for that day. We're going to test a generator, we're going to test 2 UPSs, 4 static switches, and 16 RPPs. That's our plan for today. We're going to do it from 8 a.m. to 4 p.m., and we're going to do the next shift from 4 p.m. to midnight. Get into that granularity. Let everybody know so that they can plan their day and their resources. Give percent complete on your level 4s to show progression, to show that you're moving forward and that you're not falling behind. It's quite important that your scheduling tool be Microsoft Project or Primavera or one of these applications. Don't try to just do something in Excel unless you're really good at Excel and you can provide updates. But if things shift, you need to have the flexibility to move your resources around and show that you still have the appropriate manpower to do that work. So now, outside of the module, the traditional data center approach still applies. You need to account for failures, you need to plan for retesting, and then you need to witness any of the CX issues and close them out. You're going to run into a high level of deficiencies during commissioning of this type of data center. A lot of it's going to be related to the building automation system. The components are pretty rock solid. And I haven't run into many breakers that have ever failed. I haven't run into many crack units that haven't worked. But what I've run into is a lot of the building management system and just the hundreds of thousands of points you're pulling for a data hall aren't working correctly or aren't linked correctly. So understanding you have to spend time to go back and do that. So it's going to require long days and long nights by your team. Have a safety plan in place. Don't work your teams to 14-hour days. Keep it to 8-hour shifts. But maybe you have night shifts and day shifts. So once you've completed all your level 4s, now you're working towards your integrated systems test. You're going to have multiple integrated systems tests. You might want to pre-test as a simulation to make sure everything works. What we're talking about are heat load tests in your data hall. 10 megawatt data hall, you're going to have 10 megawatts of load banks in there. Crank it up to 10 megawatts of heat. Watch everything work together. Make sure you have visibility. Make sure you've got your transient recorders in the right place. Make sure the BMS is trending and visible. Make sure it all works before you start doing it. Then actually do your level 5 testing. You're going to go through all the critical failures of components. You're going to test your N plus whatever capacity, N plus 1, N plus 4. You're going to start failing equipment. Then you're going to do the same thing on your electrical side. More than likely you have, the 5 nines rule or maybe even the 7 nines rule on your electrical power distribution. Take it to that level of failures. Fail a generator, watch it roll over. Fail a UPS, watch it roll over. Fail a singular utility, watch it roll over. Fail the full utility. While you're on emergency power, fail another generator. Watch it cascade, watch the system react and work. This is your time to prove to the owner and to the end user that these systems will indeed work what they need to do. These are quick activities. We're talking 10 to 12 hour days for 2 to 3 days and your level 5s are done. At this point, you've gone through all of your CX issues that you found during level 4, so you know everything's going to work. Now you're just proving it, documenting it for everyone. Your level 6 activities really are just your final commission report, closeout documentation, training if you had any scope, operations and maintenance review if you had any of that scope, and you're turning that deliverable around. We're seeing our commissioning authority turn that around in about 5 days. That way the client has it. He can go to his end user and say, here's your data center, completely work. Now that you have other components that need to be commissioned. Might not be in your scope, like security systems. They're not going to start populating a data hall until they've proved out their own security. That could take months. We recently commissioned a data center. We finished it in December. The end user didn't start doing a deployment until April. So there is a little bit of lag time, but they need to hit that ready for service date ASAP. There's contractual obligations. There's money at stake if you miss those ready for service dates. So the last thing before we head into some Q&A will be some of the challenges and lessons learned that I've encountered throughout my career, not just recently, but have a strong grasp for the schedule of each level. That's the hardest thing to understand when you're talking about a delivery method of 9 months. 3 of those months are actually in the factory, so you're only talking about a 6-month build where the power module and all the other components are brought together. A month and a half of that is your level 4 and level 5 commissioning. So you've really only got about, 3.5 months of construction that you can observe in the field that matter for your MEP systems. So you have to understand how the nuances of all those levels play together and where you want to focus your time. Have a large, fast-reacting team. Not a lot of commissioning authorities I know have the luxury of having 20 people on standby waiting just to go to a data center and commission it. So if you have to team up with a partner, a local partner, use that as a great resource. Somebody that can provide on-site presence, somebody that has 4 or 5 qualified, mechanical commissioning authorities and a couple electrical commissioning authorities to support you. Don't take on more scope than you're comfortable doing because there's too much at risk. Understand the client delivery schedule and how that incorporates into commissioning. What I'm talking about there is while you're doing your level 4 and level 5 commissioning, you have load banks in the data hall, but the end user wants to start bringing in racks for early turnover. How is that going to affect your layout and your commissioning plan? So if you define your commissioning plan, again, during level 1 and level 2, you're coordinating and communicating with your end user. They understand where you're going to be, and you work through your owner's rep or your CM to limit access. Does your scope just focus on the functional testing? Are you doing anything as it relates to factory testing and site acceptance installation testing? Understand, don't bite off more than you can chew, so work with whoever you're developing your proposal for to develop a scope that meets your qualifications and their needs.